Hello everyone. In this section we will discuss some more examples based on completing the square method. First one is find the inverse LT for the following function s square divided by s raised to 4 plus 4a raised to 4. Solution: f bar of s is equal to s square divided by s raised to 4 plus 4a raised to 4. Now this is of the form f bar of s divided by ps square plus qs plus r. We have to convert this numerator is in the form of denominator is in the form of s minus a whole square plus r minus b square. For that, consider s raised to 4 plus 4a raised to 4 is equal to, we have to express this s raised to 4 plus a raised to 4a raised to 4 as s minus a whole square plus r minus b square. I will write this s square s raised to 4 plus 4a raised to 4 as s square whole square, because s square whole square is again s raised to 4 plus 2a square whole square. Okay, see here we have here positive sign, so that we have chance in a plus b whole square formula, so that we know that a plus b whole square is a square plus b square plus 2ab. Okay, now consider for the given function s square as a, then it is a square plus 2a square as b, therefore it is 2a square whole square. S square as a square as s square, therefore it is s square whole square, and b as 2a square, therefore it is 2a square whole square, plus then a plus b, a 2 into ab is 2, a square, a value is s square, b value is 2a square. Okay, therefore it will be s square whole square plus 2a square whole square, plus it will be 2 to the 4 s square a square. Okay, this is as s square plus 2a square whole square. Okay, see, I am considering these two terms, a square as s square and b as 2a square, then 2ab will be 2s square 2a square, therefore it is s square whole square plus 2a whole square plus 4a square s square. This can be written as, this is of the form a plus b whole square, a value is s square, b value is 2a square, therefore it is s square plus 2a square. But I have only these two terms in denominator, so that I have to add for a to write a plus b, a minus b whole square form, we have to add 4s square a square and subtract 4s square a square. We get s square whole square plus 2a square whole square plus, first I will add 4s square a square, then subtract 4s square a square. Okay, now which is equal to, this three terms gives us s square plus 2a square whole square minus 4s square a square as it is. This can be written as s square plus 2a square whole square minus 2sa whole square. See, this is of the form s minus a whole square minus b square. Here a value is minus 2a square. Okay, therefore s square divided by s raised to 4 plus 4 a raised to 4 can be written as s square divided by s square plus 2a square minus 2sa whole square. Okay, now we can't adjust the after this one we have to express the numerator in terms of s minus a. Here a value is 2a minus 2a square. On seeing these terms we can't adjust the numerator as s minus a, so that s square divided by s raised to 4 plus 4a raised to 4 is equal to s square divided by, see this term, this is of the form a square minus b square. We know that a square minus b square is a plus b into a minus b. Okay, here a value is s square plus 2a square and b value is 2as, so that it is s square plus 2a square plus 2sa or 2as into s square plus 2a square minus 2sa. Okay, now denominator work is over. Now we have to express the numerator in terms of this one. So for that, consider, first I will add these two terms, s square plus 2a square plus 2sa plus s square plus 2a square minus 2sa is equal to this plus 2as minus 2as get cancelled, remaining is 2s square, here 4 plus 4a square. Okay, see here in numerator we have only s square term. To get 2s square plus 4as, I have 4a square. First I have to multiply 2, then add, subtract 4a square. This is not possible to express this numerator in terms of this one when we add the denominator terms. So that I will consider s square plus 2a square plus 2sa minus, here it will be s square, then it is minus 2a square, minus into minus plus 2sa, which is equal to plus s square minus s square plus 2a square minus 2a square get cancelled, remaining is 4sa. Okay, see in numerator it will be 4as only when we multiply this term to s and divide to 4as, means only 4a, it will be s square. For to get s square, just multiply this to s and divide 4a. Otherwise you can also write it as s square divided by s raised to 4a raised to 4 is equal to, in this s square I will take one s outside, divided by s divided by s square plus 2a square plus 2as or 2sa, s square plus 2a square minus 2as. Okay, to get this 4as I will multiply it to 4a and divide 4a to this one. I will get 4a divided by 4a. See in numerator I will get 4as. We know that 4as is subtraction of these two terms, so that I can write 4as as s square plus 2a square plus 2as minus s square plus 2a square minus 2as. Okay, to get 4as just I am taking s can be written as s into s. I am taking one s outside and I am multiplying and dividing 4a to this term. I will get 4a s divided by this one. To balance this one, I am dividing 4a, therefore it is s divided by 4a. Next step, in place of 4as you can write this subtraction of these two terms. We get, see here, for taking numerator this is not possible, so that I am writing here not possible. Okay, s square divided by s raised to 4 plus 4a raised to 4 is equal to s divided by 4a as it is. I will write in place of 4as as s square plus 2a square plus 2as minus s square plus 2a square minus 2as divided by s square plus 2a square plus 2as into s square plus 2a square minus 2as. See, in numerator I have two different terms, so that I will separate those terms. S divided by 4a keep as it is, s square plus 2a square plus 2as divided by s square plus 2a square plus 2as into s square plus 2a square minus 2as. Okay, first term is over, minus for this one second term s square plus 2a square minus 2as divided by s square plus 2a square plus 2as into s square plus 2a square minus 2as. Okay, see here, in numerator and denominator we have same terms, s square plus 2a square plus 2as, s square plus 2a square plus 2as, so that these two terms will cancel. Here this term will cancel, remaining is only s divided by 4a into 1 divided by s square plus 2a square minus 2as minus 1 divided by s square plus 2a square plus 2as. Okay, now in this method I have to replace replace means we have to use the result as L inverse of f bar of s minus a is equal to e raised to at into f bar of s. For that we have to take the terms express the terms in terms of s minus a. For that I will take this denominator, consider s square plus 2a square minus 2as. See, this can be written as s square plus a square minus 2as plus a square. See, we have 2a square, so that I am writing just a square separately. On seeing these two terms, we get a square plus b square minus 2ab, so that it is a value is s minus a whole square plus a square. Then for this one, s square plus 2a square plus 2as is equal to s square plus a square plus 2as plus a square. On seeing these three terms, we get s plus a whole square plus a square. Therefore this term can be written as this one, and this can be written as like this. After that we get s square divided by s raised to 4 plus 4a raised to 4 is equal to s divided by 4a keep as it is. First term is 1 divided by s minus a whole square plus a square minus 1 divided by s plus a whole square plus a square. Okay, now I have to apply the inverse, L inverse of s divided by s square divided by s raised to 4 plus 4a raised to 4 is equal to, here 1 by 4a is constant, then I will apply, then multiply this s into these two terms separately, therefore it is s divided by s minus a whole square plus a square minus L inverse of s divided by s plus a whole square plus a square. Okay, next it is equal to, next I have to express the numerator in terms of s minus a, so that I will add and subtract a to upper terms. Here I have minus a, so that I will subtract a and then add a divided by s minus a plus a square minus L inverse of, here I have s plus a, so that I will take first add a then minus a divided by s plus a whole square plus a square. See, I will take s minus a for the bracket, and this is for bracket only for identification of s minus a and s plus a terms. We know that L inverse of f bar of s minus a is equal to e raised to at into L inverse of f bar of s. So that change s minus a to s and also s plus a to s, because in first term I have s minus a, here s plus a, this will be s, and this is also s, here it is s, s plus a as s and s minus a as s. Now s square divided by s raised to 4 plus 4a raised to 4 inverse, L inverse of this one is equal to 1 by L inverse of s square divided by s raised to 4 plus 4a raised to 4 is equal to 1 by 4a as it is. L inverse of first term will be s plus a divided by s square plus a square here we have e raised to a into t, because f bar of L inverse of f bar of s minus a is equal to, this is wrong, is equal to e raised to at into f bar of s minus a. Therefore it is e raised to at into L inverse of s plus a divided by s square plus a square minus e raised to minus at into L inverse of s minus a divided by s square plus a square, okay, which is equal to 1 divided by 4a. And now again I have two terms here, for that in this, for these two terms e raised to at is common. Now L inverse of s divided by s square plus a square, here I have plus sign, therefore L inverse of a divided by s square plus a square, first term is over, then minus second term I will write here minus at into L inverse of s divided by s square plus a square, minus sign I have here, therefore L inverse of a divided by s square plus a square. Okay, all brackets are completed. Okay, which is equal to 1 divided by 4a e raised to 80 as it is. L inverse of s divided by s square plus a square is cos 80 plus this is sin 80 minus sin it is e raised to minus 80 as it is cos 80 minus sin 80. Okay, now multiply this exponential form, we get e raised to 80 cos 80 plus e raised to 80 sin 80 minus e raised to minus 80 cos 80 minus into minus plus e raised to minus 80 sin 80. See here, sin 80 I will take 1 divided by 4a. For cos terms, e raised to 80, this is minus e raised to minus 80 into, in these two terms cos 80 is common. Next, in these two terms sin 80 is common. Here I have positive sign, e raised to 80 minus e raised to minus 80 into sin a t. Now in this 4a I will take 2 inside, it will be e raised to 80 minus e raised to minus 80 divided by 2 into cos 80 plus e raised to 80 minus e raised to minus 80 divided by 2 into sin a t, which is equal to 1 by 2 remains as it is. We know that e raised to 80 minus e raised to minus 80 divided by 2. Here we have minus sign, therefore it is sin h80 hyperbolic sin hyperbolic 80 into cos 80 plus, this is for plus because both the terms having positive sign here, therefore it is plus, this is a cos h80 sin a t. This is the required L inverse for the function s square divided by s raised to 4 plus 4a raised to 4. This is the required result for the given function s square divided by s raised to 4 plus 4a raised to 4. This example is somewhat lengthy, but you have to understand stepwise and try this example. This is homework example. This is given, find inverse LT of s divided by s raised to 4 plus 4a raised to 4. Only difference is in your given example, for the previous example you have s square, here it is s. Try this example. If you have any doubt, contact me. I will explain how the terms will come and how you have to simplify. In this type of example, you have to perfect in factorization or arrangement or expressing the denominator terms in terms of s minus a and numerator terms in terms of s minus a, and you have to apply the results which are suitable for rearranging the terms.